Moscow, Soviet Union, 24th of June, 1941. Before dawn, Moscow's freight yards lay under blackout. Flat cars waited in rows. German spearheads drove east, and the capital's core factories risked capture or ruin. This is how one council turned trains into lifelines and lifted production in war. Orders stood ready. Hours, not days, would decide what could be saved. The Council for Evacuation, central body to move and reassemble factories, began work that morning, chaired by Nikolai S.H. Vernik, with Alexei Kosygin executing decisions and Joseph Stalin approving them. It sent machine tools, crews, and entire production lines toward the Urals, Siberia, and Central Asia. In the months that followed, more than 1,500 factories moved, a city's worth of industry spread across thousands of miles. The trains left before the front arrived, and, against the odds, production not only recovered but rose. Telegraph keys rattled in Moscow as clerks typed factory names onto orders. German armored columns cut highways by the day. Industrial centers faced capture. A new council would decide who got trains, where they went, and how to rebuild. On the 24th of June, 1941, the Soviet government created the Council for Evacuation, a wartime body with one job: move industry out of danger and make it work again. Nikolai S.H. Vernik chaired it. Alexei Kosygin ran operations. Joseph Stalin approved its mandate, making its instructions binding across ministries and republics. Before this, orders ran through separate commissariats, each guarding its own plants and cars. The council tore through that fragmentation. It centralized rail transfer and reassembly for factories in threatened zones. Directors received a single command chain and a phone number that mattered. The NKPS, People's Commissariat of Railways responsible for rail operations, was the muscle. Its timetables could be redrawn in hours when backed by top authority. The council could requisition locomotives, sidings, and crews, and override peacetime priorities. Plant directors needed that muscle and a unified schedule more than slogans. Its first order set triage. Plants making weapons, ammunition, fuel and machine tools, metal cutting and forming machines that build everything else, stood at the top of the list. Textile sheds and breweries would wait. Telegraph instructions summoned evacuation teams to these priority plants. Destination mattered. The council named the Urals, Siberia, and Central Asia as reception belts, beyond the immediate range of the Luftwaffe, the German Air Force. Sverdlovsk, Chelyabinsk, Magnitogorsk, Novosibirsk, and Alma-Ata became waypoints for whole workshops. From Moscow to Sverdlovsk was about 1,100 miles, roughly the distance from New York to Miami. In that depth, bombers needed forward bases they did not yet have. Rolling stock, locomotives and rail cars was finite. So were crews. Civilian traffic would be cut so that flat cars and gondolas could carry presses, forges, and boilers. NKPS issued wartime priorities. Passenger trains were dropped from schedules, and coal allocations shifted to evacuation routes. By late June, frontline movements outpaced local decision cycles. Minsk fell on the 28th. German spearheads reached the Dnieper in days. The Luga line formed under fire near Leningrad. Factories around Kiev, Kharkov, Leningrad, and the Moscow basin watched the front approach by the hour. Immediate risk forced a single switchboard for orders, or the system would fray. The stakes were blunt. Heavy industry west of the Volga made the bulk of tanks, shells, and fuel. Losing it risked having armaments output within months, when the Red Army needed more of everything. The council's promise was simple: save capacity faster than the enemy could reach it, and reassemble it fast enough to fill new quotas. Could plants decide alone? No. A director might have crates but no flat cars. Another had cars but no permission to block a main line. The council matched these parts, plant by plant, line by line, and issued dispatch orders with names and weights, not wishes. A dispatcher's board in Moscow filled with factory names, not station names. KHPZ meant the Kharkov Locomotive Works. Kirov plant meant Leningrad's heavy shop. Azovstal meant steel from Mariupol. Next to each were tonnages, deadlines, and route codes. Crews read those chalk marks as marching orders. Telegraph offices sent more than destinations. They detailed how to strip a shop to the floor. Riggers unbolted lathes and planers. Electricians tagged cables. Carpenters built skids and crates. Machine tools went first, then gauges, then spares, followed by skilled crews and the family baggage that kept them from deserting the project. The council's authority shortened arguments. If two trains met on a single-track line, the evacuation echelon took precedence. If a commissar objected, S.H. Vernick's office called Stalin's secretariat and the line cleared. The system was crude, but in a crisis, speed beat elegance. Geography shaped the plan. The Urals had ore, coal, and existing shops. Siberia had space, cold, and rail yards. Central Asia had distance from the front and labor from evacuated families. The council mapped these to needs. Magnitogorsk's blast furnaces could feed boilerplate to tank factories in Chelyabinsk. Novosibirsk could host precision shops under timber roofs. Signals mattered as much as tracks. The council issued standard packing lists and reassembly sequences. Fitters carried jigs so that reassembled lines would hold tolerances. Without those, a press would stamp but a shell would not fit a gun. Failure had a timetable. By early July, Luftwaffe raids reached the outskirts of Leningrad and Moscow, and bridges on the Dnieper came under threat. Rail yards became targets. The evacuation clock ran with the front, each day shaving slack from schedules built for peacetime. The machine moved because someone could say go and make it stick. That was the council's purpose. It pulled rail power, labor, and official attention into a single corridor of action. Authority aligned with a continental-scale task, and the first trains rolled east long before the last bolts were tightened. Freight cars stood 3 deep outside junctions east of Smolensk. Station masters darkened lanterns under blackout cloth and counted locomotives like currency. If the first trains went to the wrong plants, entire lines would die on the rails. The council promised a method, not miracles. German spearheads drove for the Dnieper crossings within days, and their vanguards probed toward Smolensk before July ended. That pace turned every timetable into guesswork. Lines that handled peacetime grain and timber now faced presses and boilers, and the rails cramped under the weight. One halt at a bridge could back trains up for 50 miles. NKPS's network had nodes it could not enlarge on command. Single-track segments forced meets on short sidings. Coal and water stops set hard limits on haulage. Locomotives were the true bottleneck. Crews could run long, but a cold engine pulled nothing. Plant directors lived in that pressure. Refugees filled yards and factory dormitories, and blackout rules dimmed every lamp and switchboard. Orders arrived in fragments, sometimes by courier, sometimes by phone, and they changed as the front moved. Directors could strip a shop in a week, but they needed a train in a day. Arguments multiplied. Commissariats pressed for their own plants and supply lines. Armaments wanted explosive fillers and fuses. Tank industry demanded engines and armor plate presses. Railways needed coal and repair shops intact. Gosplan, State Planning Committee coordinating economic plans and targets, sent tables of output and dependencies that did not match the ground truth. Cranes were a silent constraint. Few rail cranes could lift above 50 tons, and many shops owned only overhead bridge cranes that could not leave the building. A 200-ton press needed special bolster cars, lashings, and a crew that had done it before. There were not enough flat cars, and heavy-lift riggers were scarce. People competed with steel. Worker trains kept a plant's skills together, and families rode those echelons because a man with his family east of the Urals would stay. Every passenger coach meant fewer flat cars in the consist. The council cut passenger schedules but could not cut people from the plan. How to assign the first trains when all claims felt urgent. The council imposed graded lists keyed to immediate combat value. Category A moved now. Machine tool plants, cartridge and shell cases, bearings, propellants, diesel engines. Category B followed as routes and cars freed. General spares, castings, and non-critical consumer goods that still kept cities alive. Category C stayed put, prepared for dispersal or demolition if the line failed. Triage only worked if sequences held. Toolmakers and bearing works had to move ahead of the assembly halls that needed them. Without broaching machines and roller bearings, a tank plant became a shed of hulls. The council scheduled those A plants first to Sverdlovsk and Chelyabinsk, where rail yards and power could receive them, and sent assembly shops to Novosibirsk and Tashkent to wait on their tools. Geography was a chessboard with long moves. Sverdlovsk's yards could stage whole echelons under cover. Chelyabinsk had steel and power close at hand. Novosibirsk lay far enough to be safe and close enough to feed back west. Tashkent offered warmth, labor, and distance, but demanded longer hauls across steppe with few sidings. Summer helped and hurt. Dry days let crews work in the open. Rain turned cinder ballast into sponge and pumped the track under load. A sagging roadbed could drop a wheel and close a line for hours, sometimes days. Yard work slowed when storms cut power and flooded pits under crane rails. Security fears bled time. Rumors sparked panics that sent workers home to fetch families mid-load. Sabotage could be as simple as swapping destination tags on a rack of crates. The NKVD posted guards on platforms and required telegraphed confirmations before trains moved, but no net caught everything. Labels mattered. Crews chalked route codes and car numbers in big letters because paper waybills tore in rain and blackout. One missed meet on a single-track stretch could push a priority echelon to a siding all night. The cost was real. A lost connection might idle an artillery plant's reassembly for a week, while rifling machines sat 2 junctions behind. The council tightened the system step by step. It set a locomotive pool for A-list echelons and banned local diversions without a central code. It scheduled worker trains in the gaps left by machinery moves, often at night when yards ran cooler. The plan did not end confusion, but it channeled it. Every decision carried a trade. Moving a press today meant 1,000 families waited tomorrow. Keeping an engine on an evacuation run meant coal stockpiles at a depot ran low. The council accepted these costs because delay was worse. By forcing the lists and guarding the sequence, the council kept interdependent parts in motion. Bearings arrived before cranks, gauges before barrels, presses before hulls. The next problem lay ahead in the east, turning crates into working lines under rough roofs and snow. Moscow, Soviet Union, 30th of June, 1941. By noon, Telephones rang without pause inside drafty offices off Red Square. Trains loaded with lathes and presses waited at signals for a word with teeth. The word arrived when a new body took control of the war economy. This is how law, links, and enforcement turned orders into motion before the front erased options. The GKO, State Defense Committee, wartime supreme authority from the 30th of June, 1941, sat above all commissariats. It absorbed emergency powers and set a single chain of command. The Council for Evacuation fell under its oversight, which made its rail orders binding across republics and sectors. A promise on paper became a locomotive in steam when GKO decrees backed it. Tools mattered. The Council now could requisition locomotives, redirect routes, and suspend civilian traffic under GKO decree numbers that dispatchers knew by heart. A NARCOM, People's Commissariat, a ministry with sector authority, stood answerable for packing materials, crews, and complete inventories on set deadlines. Binding orders listed car counts, axle loads, and seal numbers, and the named NARCOM had to deliver the pieces when the train arrived. Failure was not a memo. It triggered an investigation. Enforcement sat close. The NKVD, Internal Affairs Commissariat tasked with site and rail security, posted guards at loading bays and ran escorts on priority trains. Wartime statutes allowed demotions or arrests for diversion, theft, or delay that threatened defense output. A plant that tried to hold back a machine tool for local use found an NKVD major at the gate by evening. The knowledge shortened arguments before they started. The Council issued model orders to strip friction from a chaotic task. Standard forms defined crate numbering down to shopline machine so that crews could stage reassembly without hunting. Lead seals carried a unique stamp. Broken seals meant a search at the next junction. Escort protocols specified who rode the train, who held the waybills, and who had authority to cut cars when a locomotive failed. Field teams carried that system into factories. Council envoys embedded at plants verified inventories, checked crates against lists, and watched the last bolt go into the skid. When loads met the standard, an envoy stamped an evacuation certificate and telegraphed, "Ready." That stamp unlocked a reserved path that ran across multiple rail districts under a code every dispatcher recognized. The path was not a metaphor. GKO reserved locomotive pools for evacuation echelons and assigned them priority numbers that overrode regional schedules. A dispatcher at a distant junction did not have to guess. The code told him to clear the line, hold locals, and keep water towers ready. One certificate tied together sidings in 3 oblasts that rarely coordinated in peacetime. Gosplan State Planning Committee, coordinating economic plans and targets, kept the lists honest. It translated evacuation schedules into coal, timber, nails, canvas, and labor quotas, and reshuffled them when the front moved. A week's worth of packing material for a bearing plant meant tons of lumber and paper, plus wire for seals and fuel for sawmills. Crosswalk tables mapped those needs to real stockpiles so that crates did not sit half-built for want of rope. The clock ran fast by design. Packing windows were measured in 24 and 48-hour blocks, with 72 hours allotted for the heaviest shops. Telegraphs carried daily readouts of promised, loaded, dispatched, arrived, and the Council compared them to planned targets each night. Time pressure preserved momentum and discouraged quiet diversion of cars to local errands. Friction still rose where lines crossed. A regional rail chief might demand his crane back before a 180-ton press could be lifted. A tank narcom might argue that engines deserved the next open path over propellant mixers. The escalation path was clear. The council elevated disputes to GKO duty officers for same-day rulings, and the losing side adjusted before morning. Those rulings traveled fast. GKO could reassign a heavy-lift car from the Volga to the Urals with a phone call and a one-line decree. It could order a detour around a sabotaged bridge and make the new run legal in every district it crossed. In wartime, legality meant power at the switch. Continuity kept the machine from grinding down as new plants entered the queue. Directive templates set out who did what, when, and with which stamp. No plant director had to negotiate a fresh process under fire. The council updated lists when a city fell or a river line broke, and the same forms carried new names and tonnages. The system scaled because the paper stayed the same while the map moved. Transparency closed the loop. Daily Telegraph summaries listed consignments by plant, car count, and route code against the month's evacuation plan. Red marks meant a miss, black meant a hit. Both drew questions at the next review. The figures focused attention on real trains and crates, not slogans. By early July, authority, process, and force aligned just enough to hold a corridor open. A stamped certificate and a recognized code turned a shed of machines into a moving factory with rights on every signal. The hard part lay ahead, after the train stopped. Wiring, leveling, and meeting quotas under strange skies and first snow. By early July, eastbound traffic funneled through three main corridors. Trains left via Yaroslavl, swung through Gorky, and rolled past Kuibyshev toward the Urals. A misrouted echelon lost days and risked capture. The plan promised precision at continental scale. Dispatchers imposed clockface slots, fixed departure times repeating each hour, to tame handoffs between rail regions. A plant's echelon got the 10:20 slot at Yaroslavl and the 14:20 slot at Gorky, day after day. That rhythm simplified meets, watering, and crew changes, and let districts plan without guesswork. The council reserved priority paths across boundaries, so a code on a train meant the same thing in every timetable it crossed. The heavy work started before a locomotive whistled. Designated marshalling yards, rail yards where trains are assembled, pre-staged flat cars, cranes, slings, and rigging crews. Load plans matched crate manifests to car types and balanced axle loads, so a 20-ton lathe did not ride next to another 20-ton lathe on the same truck. Car-by-car diagrams traveled with the train so any junction could reassemble the consist if a cut-end shunt split it apart. Traceability reduced friction. Train numbers mapped to plant codes for real-time telegraph tracking, so E417/KHPZ told every operator what was aboard and why it mattered. Station clerks wired 3 signals at each stop: in, ready, out. Movement boards in Moscow and Sverdlovsk updated together, minute by minute, and flagged delays long before a plant manager heard a rumor. One missed entry triggered a call, not a search party. The corridors ran two-way by design. Once machine tools went east, backhaul, return leg of a freight trip, carried coal, steel, and boiler plate west to plants still producing behind the front. Empty miles were waste. The council kept them rare by pairing flows and building loop schedules. A train that delivered presses to Chelyabinsk might leave the same night with Magnitogorsk plate bound for barrel shops on the Volga. Bombs and breakdowns were expected, not exceptional. Rail gangs with spare sleepers, railroad ties, rails, and fish plates staged near known weak points and rolled with hand cars and light engines. When a raid cut a line, a repair crew cut the clock. triage in minutes, temporary fix in hours, full restoration in days. Telegraphers carried a parallel track, pushing alerts and detours ahead of the damage so priority trains slowed but rarely stopped cold. Bridges were the real choke points. Major river crossings were single points of failure, so the plan built in diversion routes and timing offsets. If the main span closed, echelons rerouted 2 districts south and took the slot left empty for that purpose, with interval gaps to prevent bunching at the next yard. That cost time but not the train. Waiting on a bridge meant a queue, moving on a detour preserved cadence. Heat changed the math on grades. Boilers ran softer in summer and rails expanded and lost a bit of bite. The answer was a weather buffer, extra locomotives assigned to helper duty on long climbs and hot afternoons. Derate, planned engine power reduction in adverse conditions, was built into the schedule, not discovered on the hill. Water and coal stops were pulled forward by one station when temperatures spiked. What if a key set of gauges missed its slot? A dedicated courier car, single car carrying urgent cargo, could be added to the next priority train and sent through on the same code. Those instruments rode under guard with their own waybills and could overtake the main echelon by taking a different corridor and tighter stops. The loss of an hour hurt. The loss of a week killed a line. Security rode with speed. NKVD escorts reduced looting and kept seals intact at night stops when blackout hid everything but the watchman's breath. Escorts carried bolt cutters and authority to split cars in an emergency without wrecking traceability. If a wagon went bad on a bridge approach, they ordered a cut, pushed the car into a siding, resealed the rest, and wired the code ahead so receiving yards knew to expect one less flat car, not a mystery. Distance set the stakes. Routes spanned over 1,000 miles, comparable to crossing Western Europe, and wartime speeds seldom exceeded a fast bicycle in average. The corridors made that span manageable by turning it into known beats. This junction at noon, that bridge at dusk, that yard after midnight. When those beats held, echelons arrived like metronomes, and the yards in the Urals could stage crews and power for a reassembly that started before dawn. By late summer in the Urals, surveyors paced empty lots with steel tapes while the trains were still loading in the west. Foundation pads lay chalked with shop numbers. Anchor bolts stood in wet concrete where planers would sit. Power crews strung feeders to dead switches and left them tagged, ready for a first throw. Every prepared hole cut days from reassembly, and days meant weapons at the front. Temporary works went up first. Timber sheds rose over leveled ground, with tar paper roofs and plank floors tight enough to square a lathe. Steam lines ran from mobile boilers, so metals could be machined warm and stable under roofs not yet complete. In foundry yards, the first castings poured while brickwork continued, the gantry cranes working under open sky. Sequencing governed everything. Heat treat furnaces, quench tanks, and the main machine tools arrived before the final walls and offices. A temporary bus bar, rigid power conductor feeding high-current lines, hung on timber poles, carrying electricity to the first bays. If grid power lagged, a generator train stood by to feed the switchgear until the substation tied in. People arrived in sequence 2. Advance crews from origin plants left with the first crates, carrying layout drawings and the memory of how lines ran best. They trained local teams and new evacuees while the tools were still in skids. Origin quality men followed, bringing gauge blocks, precision reference blocks for calibration, and certifying jigs and gauges on arrival to cut rework later. Targets were explicit. The council set reopening dates in 3 steps. First sparks, first batch, full shift. First sparks meant power up and a test cut through scrap. First batch meant parts passed inspection and shipped. Full shift meant 3 crews filled the day with no dead hours between. Telegraphed reports to Moscow used those marks as control points, and missed dates triggered new coal, labor, or crane allocations before delay hardened into habit. Consolidation accelerated the ramp. Evacuated shops merged into existing plants to share cranes, boilers, and power feeds, rather than rebuild a full works from scratch. In Chelyabinsk, the tractor plant absorbed engine and machining shops from the west. Kharkov crews rejoined Ural shops and brought their patterns and fixtures. The V2, 12-cylinder diesel engine for T-34 tanks, found a permanent home there, and tank assembly compressed because engines, armor plate, and transmission lines sat behind one fence instead of 3. Supply links were scheduled to the hour. Bearings reached the bays where crankshafts were already on V-blocks. Propellant lots hit filling plants only after mixers and presses passed their heat-up tests. Armor plate rolled in from Magnitogorsk on the nights when weld crews stood ready in fresh sheds. Calendars hung over dispatch desks with delivery windows inked next to machine arrivals, so that no crew saw a green light and an empty bench. Standard parts made those calendars easier to hold. The council pressed for simplified product variants and common subassemblies that reduced changeovers and scrap. GOST, Soviet State Standards for Parts and Materials, gave a language for that simplification. Common fastener sizes, shared bearings, and standardized gauges. A line that cut one profile for 3 models stayed hot longer and wasted less steel. The work never stopped at midnight. 3-shift schedules used the same floor space around the clock, with cleaning and minor maintenance slotted into handovers. Barracks rose alongside shops so crews could walk to the floor and back in minutes, and canteens served on the shift to keep lines fed and moving. Rations and coal for heating tied to the ramp milestones. When a plant hit first batch, it unlocked higher food allotments and fuel for the boiler house, fixing labor to the site through the first freeze. These measures compressed calendar time. A furnace lit on Monday, a test bar cut on Tuesday, gauges signed off on Wednesday, and a first batch sent under escort on Thursday. The telegraph back to Moscow marked that first accepted batch, and the code on that wire flipped downstream schedules from prepare to produce. In the east, roofs were still rising, but the machines were already earning their keep. Snow crusted the freight platforms near Stalingrad in the winter of 1942. Crates under canvas showed stencils from Sverdlovsk and Chelyabinsk, not from the Don Basin. The city's defense drank in shells, fuel, and spare parts from workshops reassembled beyond the Urals. This section measures how that shift held the line and reshaped a map. About 1,500 plants moved under the council's direction, a stream equal to relocating dozens of factories every week for more than a year. The flow did not vanish into storage. Hundreds of shops restarted within months of departure from the west, some cutting test bars within weeks under timber roofs and frost. The ramp ran in steps, first sparks, first batch, then full shifts that filled days without idle gaps. The calendar shortened not by slogans, but by usable parts on outbound cars. The output arc bent upward. By 1942, key armaments regained pre-war momentum despite the loss of Western mills and yards. In 1943, production outpaced 1940 levels, notably in tanks, field guns, and ground attack aircraft. T-34 hulls and 76mm barrels rolled in numbers that fed the fronts at Moscow, then Stalingrad, and finally Kursk, where the Red Army fought the largest armored battle in history. The fact mattered at the front. Uninterrupted supply replaced lost ground with steel and fuel on time. Railways became an instrument of command, not merely a mode of transport. Priority codes on trains functioned as enforceable orders, and dispatch boards displayed a moving schematic of the war economy. Central authority enforced triage so that bearings, gauges, and machine tools led the way. Local crews improvised within deadlines, building floors from green lumber, stringing temporary bus bars, and reworking crate lists when a bridge closure forced a cut. That pairing, hard priorities with bounded improvisation, converted paper plans into throughput. The human dimension anchored the machines. More than 1 million industrial workers resettled east with several million family members, a movement equal to relocating the population of a large modern city. Barracks and canteens went up beside bays so crews could walk to work and stay. Families stabilized staffing in receiving plants because a worker with his household across the Urals did not slip away after the first snow. Rations and fuel linked to production milestones tied survival to output in precise, legible steps. The trade was plain. Short-term shocks, crowded yards, thin food, disease, and accidents rose in the reception belt. But the move bought survivability and scale. The Urals, Siberia belt matured into a permanent industrial core after the war. Sverdlovsk, Chelyabinsk, Magnitogorsk, and Novosibirsk kept the heavy shops, power feeds, and housing built in crisis and expanded them in peace. The industrial geography of the Soviet Union tilted east and stayed there. Did central control slow innovation? It narrowed choices and favored simplification over variety, which reduced redesign and changeovers. That choice sped throughput when time was decisive. Fewer variants of tanks and guns, shared bearings, standardized fasteners, and repeatable jigs meant lines ran hot. Constraint also forced process innovation. Plants learned modular setups, common fixture schemes, and rapid leveling methods that cut days from every new line. In war, these were the innovations that counted. The numbers carry a comparative weight. Thousands of train loads crossed more than 1,000 miles, at wartime speeds that averaged little faster than a cyclist over a day. Yet the process held cadence. Dispatch slots repeated, repair gangs closed breaks in hours, and backhaul moved steel and coal west to interim shops. Restart speed translated directly into battle supply, and battle supply turned into operational options, a counteroffensive at Moscow, an encirclement at Stalingrad, and a prepared defensive depth at Kursk. Institutions kept the lessons. The directive templates, packing standards, and rail priority codes written in 1941 informed later Soviet emergency logistics. Civil defense planning, disaster response, and large projects reused the core ideas. Triage with enforceable deadlines, standard forms, reserve transport, and clear escalation paths. The wartime committees disbanded, but their methods persisted in ministries and planning staffs that could still stamp a code, clear a line, and move a plant. The hinge was a decision in Moscow that aligned authority with rails and time. It turned trains into lifelines, crates into working lines, and scattered workers into a new industrial belt. Output did not just recover, it rose under invasion. A single choice redirected a continent's factories and kept the war economy breathing when the map was still on fire. Flat cars rolled east from blackout platforms into daylight. The choice was loss or movement. The council chose movement. Centralized orders, enforced priorities, and synchronized rails lifted output. The eastward arc of industry outlived the crisis that created it. The trains that once waited under covered lamps now moved with purpose. The same yards that opened this story sending industry towards safety and work.